Hello everyone, welcome back to the online class of class 9 science, the physics part, and we were learning chapter number 8 motion, in which last time we were learning about the equations of motion. We were deriving the equations of motion, and in the last video we derived equation of motion number 1, that was velocity time relation. Today we'll derive the second equation of motion, that is position time relation. So here, to derive the equation, we need that same graph that we used in the previous equation. We will use the same velocity time graph. So here we'll take we had the graph like this. From this was point A, this was point B, and then it comes here, this was point C, this was the origin, and we had divided the graph, means the trapezium, into two parts. The upper part was a triangle, and the lower part was a rectangle. We are marking it D here. So this side it is time, and this side it's velocity. This was our graph that we used. And before deriving, we initialized some variables here, means where we wrote BC was taken as V, OA was taken as U, and OC was taken as T. Now after we bisect BC with a perpendicular AD on it, we get AD is equal to T, and this part BC is equal to U. And we know this, BC was divided into two parts, BD plus DC. So this much was which we used in the previous one. The same things we will also use in deriving of equation number 2, that is position time relation. Now if you see, we need to find the position. That means we need to find S, that is displacement. And here if you see, here if you find how much the object is moving from A to B, the total displacement is actually the area in this part, means the area of the trapezium OABC. That means we need to find area of trapezium OABC. Now this trapezium has been divided into two parts. One is a triangle, one is a rectangle. So we can find the area by finding the area of this triangle and summing it up, means totaling it with the area of this rectangle. So area of the trapezium, which has been divided into two parts, gives us two separate quantities. That means we have one triangle, one rectangle. So here we can write area of rectangle OADC plus area of the triangle ABD. So if we find these two areas and total them up, we'll totally get the area of the trapezium, which will give us S, means which will give us the position, or we can say the displacement. So we know area of a rectangle, formula for area of a rectangle, length into breadth. So length we can take as OC, breadth we can take as OA. So OC into OA. Then area of triangle ABD. Area of a triangle is half base into height. So half, here we can take the base as AD and the height can be taken as BD. And into height, which is BD, this much. So here again, so last time if you remember, we wrote here one more thing, BC is equal to BD plus DC, or here we can write BD is equal to BC minus CD, which we have used in the previous part also, which is BC is V, CD is U. So we can use this, or instead of using this we can do one more thing. If you remember, in the first equation, while starting the equation, we wrote one thing: acceleration is equal to change in velocity by time taken. So change in velocity was BD by the time taken, which was OC we took, and which is T. From here also we can use BD, and from here, using from there, moving this part we don't need. From here we can write BD is equal to AT. So this part we will use here. So let us see how. Let us put the coordinates, the variables that we have used. We have taken OC is T, OA is U plus half, AD is T, and BD we can take it from here, AT. So if we rearrange and settle them up, we get UT plus half AT square. So this gives us the second formula, or second equation of motion. So here the main thing you have to understand is using of this BD. So BD we have to take it from the acceleration part, A equal to BD by OC, which we wrote previously in the earlier video. If you see, you'll find there, you have written, it will be in your copy. So from there we will be using BD, so that we can get AT, and finally we can get AT square. So this much was only for today. Thank you. You can pause the video and write it down.